Students, this is your teacher at the course, and this morning we'll be talking about petroleum and natural gas. Actually, there are three states of matter for fossil fuels. We have the petroleum, we have natural gas, and then we also have what we call coal. So coal is a solid form of fossil fuel. Petroleum is a liquid form of fossil fuel, while natural gas is a gaseous form of fossil fuel. So in this lecture, we'll be talking about the fractional distillation of petroleum and of course how petroleum and natural gas is being formed. What is petroleum? Petroleum is actually a very thick viscous liquid, very dark, like the one you see on the road that is used for surfacing road. It's from petroleum. Petroleum means rock oil. That's where the Latin word was formed from. Rock oil, because you find it in the sea under some rock or between some rocks. That's where petroleum is always trapped. So if you want to tap or you want to mine petroleum, you need to dig through series of rocks. So petroleum means rock oil, don't forget. Then anywhere you see petroleum, most times natural gas will also be part of it. So you use natural gas on top and the petroleum down. So that is where you see natural gas together with petroleum. Natural gas is a gaseous hydrocarbon that consists mainly of methane. Methane is the hydrocarbon that is referred to as natural gas. However, you will see some other components like hydrogen, carbon 2 oxide, carbon 4 oxide, and the nitrogen sulfide mixed together, but in very small proportion. But the major component of natural gas is actually methane. How do we form natural gas? Natural gas is formed when plant and animal dies. When these plant and animal, when they die, they will become buried. Their dead bodies, their remains will become buried on the sea. That is, all those plants and animals that live in the sea. So over the years, these dead bodies that have been covered will become more covered by mud, by silt, stones, and plenty sediment. So as the sediment that is covering the dead bodies of the plant and animal, as the sediment begins to rise, to increase over a period of time, then the sediment on top, because of their heavy weight, they will be exerting great pressure on the sediment below. So what you see is that those sediment below will now be turning to a rock. It's called sedimentary rock because it's formed from a sediment. So as the sediment piles up, the one under it will be becoming hard and forming sedimentary rock. Remember that this sediment, those ones at the top and those in the middle, they are covering the dead bodies of the plant and animal that have died. Now, so when sedimentary rock is being formed, it will now exert greater pressure on those dead plant and animals that is under them. So this pressure, together with the temperature that is also generated and with the activity of microorganisms, all those decomposers, these dead plant and animals that have been buried will now change into crude oil and natural gas. This process always takes a lot of years, sometimes millions and hundreds of millions of years before petroleum can be formed. Now, when you form this petroleum, which is crude oil, like I've said, when the petroleum is formed, you see natural gas on top of it. Now, when you form this petroleum, the petroleum is a mixture of various hydrocarbons. Hydrocarbon means compounds that consist of only carbon and hydrogen alone. So these are the components of petroleum. Some of these hydrocarbons are short, some are medium, and some are very long and very large. So the shorter the hydrocarbon, the smaller their boiling point. So because this hydrocarbon is a mixture of this petroleum rather is a mixture of various hydrocarbon, you can separate this mixture into classes. You can group them into how large the hydrocarbon is. We call this fractional distillation, and this always takes place in a fractionating tower like the one you are seeing here in this picture. This is called a fractionating tower. So this tower is programmed to be very hot at the bottom. Then as you move up the tower, the temperature decreases like that. So it is colder at the top than it is at the bottom. The purpose is to separate hydrocarbons that have lower boiling point apart from those that have high boiling point. So when you put the crude oil into the fractionating tower, like you can see in this place where you put the inlet of the crude oil. So when you put the crude oil into the fractionating tower, what happens is the crude oil begins to boil at this bottom. So most of the hydrocarbons there, their boiling point is lower than the bottom. So most of them will be boiling. So their vapor will begin to rise up the tower. So as the vapor is rising up the tower, remember that it is colder at the top of the tower than it is at the bottom. So as the vapor is rising up, so as those vapors get to their boiling point where they are going to condense, they will condense and then come out as a liquid. So you will see that petroleum gas is one of the fraction, is one that has the lowest boiling point. It will come out at the top next to gasoline. Gasoline is another fraction of petroleum. Gasoline means petrol. It will come out here. That's next to petroleum gas. Then next to petrol is kerosene. Those are the fractions of petroleum that comes out around 200 degrees Celsius. Then those that come out around 300 degrees Celsius is diesel. Those are the groups of hydrocarbon that forms diesel. They boil at around 300 degrees Celsius. Then industrial oil or fuel oil, the one that is used for making body cream, petroleum jelly, comes out at around 370 after diesel. Then there are some that will not boil, they will remain liquid. In fact, some remain solid at the bottom of that fractionating tower. Those are the asphalt, the bitumen. So those ones will come out from the bottom of the fractionating column. So this process is called fractional distillation, a process whereby you separate the component of petroleum according to their boiling point. That's called fractional distillation of crude oil. Now, these different compounds or groups of compounds that comes out from the tower, we call them fractions of crude oil. And there are 7 major fractions of crude oil, like we have seen at the back. We have petroleum gases, we have petroleum ethers and ligroins, we have petrol, which is gasoline, we have kerosene, that's another fraction. We also have diesel oil or gas oil, the one that is used by heavy machinery. Then we have lubricating oil, the one that is used to lubricate the moving part of engines. Then we have bitumen and asphalt. These ones, they are the solid part of a petroleum that is used for surfacing road, bitumen and asphalt. So these are the 7 fractions of petroleum. Now, what we're going to do in this video, we'll talk about the fractions of this petroleum and what they are being used for. So I'll start from petroleum gases. These ones contains hydrocarbon molecule that have around 1 to 4 carbon atoms alone, from methane to butane. Butane is 4, methane is 1. So they are majorly used as fuel, domestic fuel and industrial fuel. Your gas cooker at home made use of petroleum gases, contains hydrocarbons like methane, like ethane, that number 2 carbon, propane, number 3 carbon, then butane, number 4 carbon. So these are the fraction that is used at home for cooking, that's as domestic fuel. They have some impurities, but their major function is for cooking at home. They can also be used for making chemicals, like you can see on the screen, chemicals like carbon 4 sulfide. They can be used for making ethane and the rest. When we get to hydrocarbons, we'll talk about that then. So the second fraction is petroleum ethers and ligroins. Petroleum ethers is referred to as light petroleum, while ligroins is referred to as light naphtha. So we have petroleum ethers, that's light petroleum. Then we have ligroins called light naphtha. So this fraction of petroleum are those that have 5 to 7 carbon atoms in the hydrocarbon. They distill around 20 to 60 degrees Celsius. They distill around 20 to 60. That's ethers. That's light petroleum. While ligroin distill around 60 to 100 degrees Celsius. So both of them, both the ethers and ligroin, they are used as solvent, industrial solvent. They are used for dissolving things, dissolving organic compound. Now the next, which is number 3 fraction, is petrol. Petrol is called gasoline. It contains hydrocarbon between 4 to 12 carbon atoms per molecule. Then its own boiling point is around 40 to 200. Remember, there is a mixture, so it's going to have very wide range of boiling point. So it boils around 40 to 200 degrees Celsius. The major function of petrol is as fuel for aeroplanes and for motor vehicles. Then it can also be used for dissolving grease and paint. You can use petrol to dissolve grease. So that's petrol. The next fraction is kerosene. Kerosene has higher boiling point than petrol, and the hydrocarbon inside kerosene have around 12 to 18 carbon atoms per molecules. 12 to 18. They distill over at around 200 to 250 degrees Celsius. You can see the increase in their boiling point. So they distill over at around 200 to 250 degrees Celsius. And the major function of kerosene is as domestic fuel. You know kerosene stove. They use kerosene as fuel. Then it's also used for driving tractors and jet engines. You use kerosene to drive tractors and jet engines. Remember, petrol is used for driving vehicles, normal cars and aeroplanes. But kerosene is used for driving jet engines and tractors. Those ones you see on your farm. Then it can also be used, just like petrol, it can be used for dissolving grease and also for dissolving paint. Diesel oil is the next fraction after kerosene. This one contains about 20 to 25 carbon atoms per molecules. You can see how their carbon atom is increasing and then their boiling point is also increasing together. So the boiling point of this fraction is between 250 and 350 degrees Celsius. What this oil is used for is as a fuel for heating and also for engines. We have some big engines. They use diesel, like the one you use in your school. That big generator uses diesel. Then we have some big vehicles, all those manned vehicles, those lorries and trucks. They use diesel as their fuel. Then one of the most important functions of diesel is that it is the raw material for cracking. After this video, I will do a video on cracking of petroleum. Diesel is the raw material that is used for cracking process. Sometimes you can use kerosene, but most times you use diesel as a raw material for cracking. Lubricating oil is more viscous than diesel because the hydrocarbon inside, they are the one that have more than 25 carbon atoms, very long. Imagine 25 carbon atoms joining together. So their boiling point also is very high. They boil at around 350 to 500 degrees Celsius. Now, if you redistill this lubricating oil, that is, if you reheat it again inside the fractionating tower, that fraction alone, you can get a product like Vaseline or paraffin wax, the one that is used for making cream. So you can get that one by redistilling lubricating oil, by subjecting it to heat again, and you separate different fractions of lubricating oil. You get Vaseline and then you get paraffin wax. So Vaseline is used for making hair care products. You know, Vaseline is used for making hair cream and for making body cream. While paraffin wax is used for making candles. All those candles that you normally light, they are made from paraffin wax. Then it's used for making waterproof material. Since they don't mix with water, it can be used for making ointment and also for making cream. So these are the functions of the product you get by redistilling lubricating oil. Don't forget that the oil itself is used for lubricating moving parts of engines. But you can redistill it to get paraffin wax and Vaseline. The last fraction of petroleum is called bitumen and asphalt. Bitumen and asphalt. These ones are the solid residues that are left behind. They did not boil, they just remain solid because their boiling point is higher than 500. The highest temperature you get in the fractionating tower is 500, or a little bit above that. So but this bitumen, they have higher boiling point than 500 degrees Celsius. So they remain as a solid residue inside the fractionating tower. So when you collect them, bitumen is used for surfacing roads and air feed. You can see the airways, the airline, before the aeroplane actually start to fly, it will run along the air feed. Those air feeds and our normal road, they are being surfaced by bitumen. Apart from that, the other residues, those ones are asphalt and everything, they can be used as fuel. They can be used as for pipe coating, for coating the inside of pipe and outside of pipe too. Then for making waterproof roof. You want to waterproof a roof so that water will not be leaking through it. You use bitumen. Then it's also used for making protective paint. So these are the functions of the different fractions that we obtain from petroleum. So this is where we're going to end this. In our next video, I'll be talking about how you can increase the quantity and improve the quality of petroleum. So God bless you.